Welcome, my dear students. It's nice to start the lesson today.
Hello, my dear friends. Welcome to our program for chemistry, third secondary stage.
Cations. This is the important part for these lessons. You must know about Mg, positive 2, aluminium, positive 3, different types of the cation. We will catch it. Now, let's see one after one.
Today we have cations. What's meant by cations? It's the positive charges of metals. Let's go to see the reactions and the equations of this part of our lesson. Let's go.
Chapter 2.
Chemical analysis.
Let's see what happened during these reactions. As a beginning, we have a chemical analysis. Do you think what this means?
This means we have chemical analysis. It's divided into two parts or two types of these equations. We have cations and anions.
It's a great cation and anion. What about to talk about the important role for many scientific researches? What do you see now?
We have many uses of this reaction in medical fields.
It's important to talk about the chemical field. For the first one, diagnosis of some diseases. Do you think like what? Yeah, diabetes, cholesterol. It's great and good. What about the other one?
We have another one, like what? Number 2, we have in agricultural field. What's meant by agricultural field? We have the uses of plant and improvement of soil, properties of soil by chemical analysis to know what? To know the ratio between their elements. We have some salts, we have some fertilizers that found in the soil, so we can use the chemical analysis to make this reaction, to know this information.
Good. The chemical analysis is very important. What about the industrial field? Industry, it has many things. As a beginning, chemical analysis of the ores. Do you know? As the ores of the iron, which we studied before. And also, we have a product is used in all industries field. Why? To determine its identity or identify for standard specific cations. Good.
So we have the chemical analysis of the ores, and the product is used in all industry field. Like what?
Do you know why? We must know to determine its identify for standard specific cations. Take care, we need a cations. It means we need a positive. Positive what?
Positive ion.
Good. Let's see what you see for positive ions.
So here we have another one of these fields that we use in chemical analysis in environmental field. What's meant by environmental field here?
Environmental field, why there is a haze in the air. This haze tell me the reaction between the anions and the environment. This relation is very important to tell me what happened.
Here, where does all the rain's water go? Go for what? Or go where?
Go to react with the air. This tell me main important points. This point will
explore these questions in what? In environmental topics. About what? About environmental chemistry here. So the topics in environmental science, the environment and its chemistry.
It's good to say that. When this airplane fly in the air, do you think there's a reaction? Sure. This reaction, the environment and its chemistry, is designed to introduce a general chemistry, concepts and principle as they portion to topic related to the environment. These courses of the environment for the chemistry very important, designed to tell me what happened, what the explanation for the anions, what is the relation between anions and the cations. This I want to catch it. Let's see how can we catch all of this. To catch it, concentrate for this reaction.
This reaction about cations and anion, this is the reaction of what? Of some kind of the metals that has cations, and we have non-metals that has anions.
Now, what about to identify the measuring the harmful environmental pollutants? Pollutants? Yeah, content in the water and food. Also, the percentage of the carbon monoxide. Take care, the carbon monoxide is very important one for environmental pollutants.
Why? Because here we have another one, like the sulfur dioxide and nitrogen oxides that produces in air. From what? From many types of industry that comes out from the smokes in the factories. So here we have the sulfur dioxide and nitrogen dioxide gases in air. There are several examples that can't be counted that are based on the chemical analysis that studied the
Chemical composition of substance. It means without these topics or without these points, we can't study. Let's fly to the important topic.
It's what? It's the types of chemical analysis. It's very important to know and study this information about the chemical analysis and its types.
Do you think it has many types?
Yes, we have many types like this.
Yeah, let's see the first one. About what you see?
About what? About the qualitative analysis.
Oh, qualitative analysis. Do you think what this point mean? I think it has a main point as
it involves the identification of the constituent of substance, whether it is a pure or a sample of salt or mixture and the several substance.
Good to say that. Sample salts. Take care from this word. Also, several substances. This we must know it now. Let's see what happened for this. It aimed to what do you think?
It aimed to estimate the percentage of each essential components of the substance. Accordingly, the practical qualitative chemical analysis should be what?
Should done the first to identify each part. Identify, add the component of the compound. I want to know this compound good or bad, big or small, what its ion, in order to be able to choose the properties quantitative method. Do you think to what?
To what? To we have the analyze them. Analyze them, it means what? It means many things about what? About the mixture and the qualitative chemical analysis.
Do you think there is a big relation qualitative? Yeah, qualitative here, it helped me to know we mentioned that. Qualitative analysis aims to know the component of the substance, whether it's it's what do you think?
It's a pure substance or mixture. Pure substance, it means what? It means compound, it's a pure, or element in a pure state. And we have mixture, two or more different types of substance that mix to each other, of several substance, like compounds, like many things like this, and etc.
Yeah, extra. It means we have a lot of that. What about to say if it's a pure substance, then can be identified by their physical constants. Oh, physical constants as what do you think?
As melting point, boiling point, molar mass. What's meant by each one of them? Melting point, it's the point or the degree that change between the solid to liquid by heat energy. It is one of the qualitative analysis type. And we have the boiling point, okay? And we have another one that's called the molar mass.
Molar mass and so on. We have a many things that we studied before for the last years. What about the other one? Now, anions. This experiment shown in this package may pose a certain hazard. Students, should we know what happened?
This video clip, okay, that's determine what? To analyze what the anion is in the sample. We can add some appropriate reagents and observe the chemical changes.
Yes, as we beginning, we get a tubes, different tubes. The following parts demonstrate the testing methods. Now, expected your observation. Chlorine ion. We sure chlorine it means Cl negative. What about to get this agent? Do you think what this means?
Yes, this is halide ion and add silver nitrate solution for the chloride here, HCl or any chloride anion. A white precipitate of what? Of AgCl that formed here. Why? Because here we have the reaction between two compounds. Solution of NH3 here and we have another one. Okay, like what?
And when we add like ammonia, when you add more ammonia, the color disappear. Silver chloride react with ammonia to produce water. Now, in addition of reprecipitation, they exposed to sunlight. Do you see what happened now? This reaction as a beginning for
Cl aqueous solution and we have Ag positive aqueous solution.
now it's finished. What about to fly to the bromide?
We have bromide and the silver nitrate solution to the solution contains the bromide ions and we have pale cream precipitate is formed.
Yeah, this is formed during this reaction because insoluble in the water, bromide not soluble. So the excess aqueous ammonia is added to precipitate and we ask why to dissolve.
To dissolve what? To dissolve the precipitate.
Good to say that.
It will be turned gray and the color change slowly. So Br, aqueous solution and silver aqueous solution give us AgBr. So here this is another one of these anions.
Yes, iodine. Iodine here also we have a silver nitrate solution containing iodine. The color will be pale yellow. So silver iodide insoluble in the water. Also insoluble in the water. So this reaction, when you add excess of the ammonia, now
We add the ammonia to dissolve this precipitate. Will not dissolve. Why?
because it's iodide. So the precipitate is exposed to sunlight. Do you think what happened for this case?
It will not change in color. So that
I think the equation will be iodine negative plus Ag positive will be AgCl silver iodide. The color pale blue or pale yellow?
Pale yellow.
Good.
in addition, the halide ions can also be identified by adding chloride water to the sample solution followed by the organic solvent. Like what?
The organic solvent as a benzene, as different things. Like you see, when you get the sample and add this organic, the anion of these samples in chloride ion, there will be no observable change. There is no changing. So the equation will be
Cl negative plus Cl2 aqueous solution. We have no reaction. Why? Because we have the anions dislike each other.
the ion here, it's a bromide. Good. The organic layer will be change these organic materials and change its color. So by adding more bromide to the chlorine, it forms the organic solution. Dissolve now, not dissolve.
Yes, dissolve now here. We have the bromine anion plus Cl2 aqueous solution give us bromine liquid and what? And Cl negative.
So the bromide changed here, the ion for this sample. The organic layer will change the purple color because the iodide ion is oxidized to iodine by chlorine water.
So the iodine dissolve in the organic solvent to form a purple color. So here the equation
I2 plus Cl2 equal I2 aqueous plus Cl2 aqueous. I2 here is good. What about to fly to the carbonate?
Carbonate ion can be identified by adding an acid such as dilute hydrochloric acid or sulfuric acid or nitric acid to the sample of this solution. What's happened after this? The sample contains
Yes, carbonate ions. The colorless gas will produce. It's a carbon dioxide. You must know that this gas allowed to pass in lime water. What happened in lime water?
lime water turn milky. Milky color like this or white color. Why? Because we have reaction between the carbon dioxide and lime water at this equation. Carbonate -2 as an anion and we have H3O plus give us carbon dioxide and what? And another salt.
Yeah, it's hydrochloric. Yes, hydrochlorate. It means hydrochlorate ions and alkaline. Now, it can tested by the red litmus paper. What happens when you get litmus paper, red one, added to the solution? Hydrochlorate ions.
It's changed into blue color like this. Why? Because here, this one, blue color, it means what? It means it is what? It is a cation. Or it has what? It has the hydroxide. We have sulfite.
Yes, sulfite ions has reducing agent, a strong oxidizing agent in the same time. When they react together, the acidified potassium dichromate solution is added to solution containing sulfate ions. The potassium dichromate reduced and
Turn from what? From the orange to green immediately. Why? Because here, similarly, we have the sulfite ion can also reduce potassium permanganate. And if it change acidified potassium permanganate solution from what?
from the purple to colorless. It's good to say that sulfite ion also react with bromine. Now it changes bromine to water to colorless. It's good to know that has no color. The equation will be
We have SO3 minus 2 as aqueous solution. And we have Cr2O7 minus 2. And this is anion or the indicator. And it's aqueous solution again. And we have in acidic medium. It's H positive aqueous solution. What will happen here?
the product for this case will be group of 3 sulfate negative 2. It means 2 ions negative plus chromate aqueous solution and produce 4 molecules of the water liquid. The second one, when you get 5SO3 negative 2 aqueous solution by manganese. Yeah, this is not manganese oxide only. No, 2 molecules of manganese, MnO4 aqueous, in the presence of 6H positive aqueous solution. This acidic medium will give
what? Will give SO4 minus 2 aqueous solution and manganese positive 2 aqueous solution also. And we have the water that separate from this one. Why? Because here, this is the manganese positive 2 and SO4 negative 2, they are dissolved in water here. So here we have the other part of this equation.
SO3 negative 2 or 2 negative aqueous solution in the presence of bromine. This aqueous also, the water liquid added to all of them. So the result for this case will be sulfate negative 2 aqueous and 2Br negative plus 2H positive. It's great to talk about all of this. Complete the other part for the chemical analysis. Let's see what happened now. For this case,
We have the analysis of what? Of the organic compounds. Here we have organic compounds. It involves the identification of the elements and the functional groups composing what? Composing the compound to identify it.
this tell me number A, the analysis of organic compound. It's involved the identification of the element and the functional group. This important for organic compound. Why? Because this composing the compound to identify it. Well, it's great. What about the number B?
Letter B is the analysis of organic compound. In organic compound, it means what? Any compound except what? Except benzene, kerosene, any one of the compounds that related to the living organism. It involves the identification and the ions which form the inorganic compounds. It included what?
Including the identification of the acid radicals. Oh, this is the first time to say radical. Radical here, it means anions, cations, and so on. As a beginning, anions of salt. Basic radical cation of salt. So we have 2 types of radical.
Yes, we have 2 types of radical. They are called anions for the salt, and this anion, it means acid radical, and the cations of salt is basic radical. So here we have the anions, it means negative ions, and the cations, it means positive ions of the salt.
We catch positive and negative. What about the detection for anions? Anions here it means what?
It means the negative ions or acidic part of the salt.
Well, let's see the example. Acidic radical. It means an ion can be classified into
3 groups. Each group has a certain reagent, and these group are what?
Are different anions of dilute hydrochloric acid group. Do you think hydrochloric acid has a groups?
Yes, we have some groups, or we have group of the hydrochloric acid. We have many things like this.
Yeah, the other one, it means anion concentrated sulfuric acid. I think this not only, we have another one.
Yes, number 3, we have anions of barium chloride solution group. So here the barium chloride, it means what? It means a salt. So the first one, again, we have the anions of dilute hydrochloric acid group, and the second one, we have sulfuric acid group, and the last one, here we have the barium chloride solution group.
Yes, I think we have the first one now, anions of dilute hydrochloric acid group. This group including many things. The following anions. Number 1, it means
Carbonate CO3, the ion. This ion is -2.
yeah. Number 2, it means bicarbonate. It has a formula
HCO3 -1.
It's good to say that. But also we have
Sulfide group, it's what? It's SO3 -2.
now, what are the difference between sulfide and the sulfite?
We have sulfites here. The first one, it's SO3. But sulfide that end with D and E, we have S-2.
Oh, this it means both of them, it has -2. It's great. The last one, thiosulfate with the formula
S2O3 -2 as an ion.
Also, all of these ions contain -2. This is important for the reaction. For last one,
This is what? This is nitrite, NO2 -1 or -1 as an ion.
good. So the different radicals here will react as +2 or -1. What about to see testing for anions carbonate? Now, place 2 ml solution into test tube. So,
Add equal volumes of nitric acid to remove other anions.
good. This anions, when it's removed, we are ready now. By aqueous barium nitrate, white precipitate is formed as you see. It's great and good.
So here, this one of the precipitate, barium nitrate and white precipitate that formed in this reaction.
Good. What about the equations? Observation and inference for this. These equations very important, and also we must fly to the other one. Solution contains
the hydrochloric acid and add an equal volume of dilute hydrochloric acid HCl to what? To the anion here. So here what will happen? The 4 carbonates here or bicarbonate, we have carbon dioxide that produced from carbon dioxide gas produced, and they change the lime water into milky color that make precipitate with lime water.
so this precipitation back to formation of carbonate group. It has this color of the white precipitate. The equation very important. CO3 to negative aqueous solution will be evolved. If you get the other one,
Place 2 milliliter of solution into test tube, and we have the add equal volume of aqueous silver nitrate for this. Immediately we have what? We have a precipitate that formed here. Why? Because here this is silver nitrate and HCl that form the mixture into two
portion. So this portion of 2 white precipitate for 2 different tubes. Now, do you think are similar now? Yes. Add drops of nitric acid.
to what? To make the experiment number 1 until it's what? Until it's excess. Add the acid here many times to make what? To make this is excess of nitric acid here. Why?
To form and tell me what is the reaction. If you add aqueous ammonia here, excess of the ammonia, this reaction must be shaking from time to time. Do you think what happened now? The color will?
Yes, the color it disappear. Why? Because the white color, we have what? We have dissolving this compound in the ammonia solution. So place 2 milliliter of the solution into a test tube. And we have another thing here. We have another part, equal volume of nitric acid to remove the other anions.
Good. Let's see the anion. It's silver nitrate. Pale yellow precipitate is formed, as you see. When you add silver nitrate, this shaking increasing the amount of the yellow precipitation. So when this color increase, tell me you have an ion of silver nitrate. Now we try to divide it to mixture into 2 portions equal in volume. Then present
The nitric acid. So dilute nitric acid, drops of it until it's in excess. Increase the volume and put some drops of this nitric acid to make the first one and shake it many times. What will happen here? We have nothing to change. So here the second one. What about the second one?
we add ammonia aqueous solution. We won't be too confirmatory. What happened? You see the color start to be disappear some part after part, time after time by shaking. So there is big difference between the first tube and second tube. Concentrate for the equation iodine and silver, all time will be AgI. Another one.
Another one, we have another experiment here, solution into a boiling tube. And we have the hydroxide or sodium hydroxide, aqueous sodium hydroxide here to make what? To make equal volume and put a piece of aluminum foil. And what will happen for this?
This reaction is very important. Moist red litmus paper. This reaction, by heating gently and warm continuously, the gas evolved and turned moist red litmus paper to important color
Is blue. We have another one, dilute hydrochloric acid group, HCl. And we have the carbonate, first one to make what? To make the reaction between them. Carbonate CO3 minus 2 or negative 2.
Now, do you think gas liberated and its detection? Detection by what? Detection by this equation. Get the first section for the reactants.
We have Na2CO3 sodium carbonate in the solid state, white powder, and HCl. Here we have acid with what? With salt of sodium carbonate. What will happen if you add them to each other?
I tell you now, but I have an important note. What about the first one? I think it has a S. Do you think what this means?
S, it means a solid.
What about a Q? I see.
It means aqueous solution.
Good. This reaction directly will produce 2 NaCl aqueous plus water liquid and the carbon dioxide gas. So this reaction is stopped?
No, we have this reaction, it's concentrate. It is what? It's continuous. And the effervescence takes place and carbon dioxide that evolve from this one and they turn the clear lime water into milky color as this equation.
This equation get carbon dioxide gas plus calcium hydroxide aqueous solution. The result here, wonderful and great. Look at this. Calcium carbonate. What is the state for this case?
This state we have what? We have calcium carbonate. It's solid state that doesn't dissolve in water liquid state. So here this type of salt, calcium carbonate, doesn't dissolve in water. So it's form what? It forms the milky color of lime water.
Lime water is important to detect the presence of the carbon dioxide. We arrived to the end. Do you understand the lesson? I think so.
concentrate with us very well in this information about the lesson. Till we meet again in another session about chemistry. Till we meet again, thank you and goodbye everybody.